I want to take a look at homework problem number 2, and I want to actually solve it in terms of all the letters, the variables that we have here. And what I'm going to do is I'm going to actually assign numbers here, not for any other purpose, but I think what happens, not for any purpose to put into formulas. I just think people get confused about what the knowns and the unknowns are in a problem. And I want to get really clear on the fact that we have a situation like this where we have a lot of variables and we're not sure what the knowns and the unknowns are. So let's just pretend I give you 2, 10, and g equals 10. You didn't need this to solve the problem. Again, these are placeholder letters, and I'm going to be solving the entire problem with the assumption that these values are given, and I'll show you why at the end. So let's draw a free body diagram of this system. So we're going to have the normal force on big M due to the table. We're going to have the weight or the gravity force on big M due to the Earth. We have the tension pulling big M forward. And we have a friction force going backwards. Given that there's 3 parts to this problem, I'm not sure whether we're going to have static or kinetic friction, so I'm just going to leave it as a little f. And then for little m, we have the tension T, and we have its weight, the weight of little m due to the Earth. Now we're going to define the positive direction as this whole motion here. Now every force that I don't know what it, every variable that I don't know what it is directly, meaning if it involves the slightest calculation, even if it's multiplying 2 numbers together, I'm going to leave that as a black letter. And these constants here will always be dropped into formulas as blue letters to remind us that we actually have a number for them even though we're not plugging it in. So for big M, we actually need to set up the equations in the y direction and in the x direction. And in the y direction, we have that the normal force actually competes with the weight. And the effect is that the block neither leaps into the air nor does it crash into the table. And we write that as a simple 0, meaning there's no acceleration in the vertical direction. Now in the horizontal direction, we've defined it this way as being positive. So we have the tension force competing with the friction force, and the effect is that big M accelerates. Now what we're going to find is for part A, the friction force actually equals 0 because we're told that the system is frictionless. And then for little m, let's remember that downwards is the positive direction, given that this motion of the pulley is what we're calling positive. So we have WME, the weight of little m, fighting with the tension, and the effect is that little m accelerates. Now let's be really careful about a couple of things. I'm going to actually change this up a little bit because we know what big M is. We actually know what it is. So that means I'm going to write this as big M, meaning we'd put in 10 there if we were putting in numbers, but we're not going to for this problem. And here we're going to write, again, I'll actually get rid of that. Oops. We'll just get rid of this, and I don't like that. So we're going to write equals minus t equals little m, which is a given, times my unknown acceleration. So it turns out this equation, when we're dealing with frictionless systems, okay, so I'll actually write this. When frictionless, when friction is 0, this equation is true but not useful. We'll actually need it though for parts B and C. So continuing on, I have an unknown tension, and since I don't have friction in part A, I can rewrite this formula to simply say the tension causes the big mass to accelerate. That's going to be equation 1 for part A. And then what we're going to do is I'm going to actually replace WMG, or WME, the weight of little m due to the Earth, pulling on it, with the appropriate formula. So we know what little m is. We know that G is 10. So that weight competes with the tension, and the effect is that little m actually accelerates. Once again, let's check blue versus black letters. So I don't know what tension is. That's why it's black. That's why it's written as just a plain letter that we don't know what it is. Big M, we know it, so we write it as blue. A, we don't know. Little m, G, we have values for those. We said that little m was 2, big G was 10. Okay. Now what we actually have is a situation of two equations and two unknowns. So what I'm going to do is I'm going to actually substitute equation 1 into equation 2, and I will rewrite. So I end up getting mg minus big M times A equals little m times A. I can now rearrange. So I'm going to get that mg actually equals, and I'm going to rearrange and factor. So I'm going to have big M plus little m times my unknown A. And finally, my acceleration in part A works out to being mg over m plus little m. So that's the acceleration, and I can go ahead and plug that back into equation 1. And when I do that, I'm going to get that my tension is equal to big M times little m times g over big M plus little m. And that is what my tension works out to be. So that is part A. I'm going to go ahead and solve part B in the next video.